Okay, good morning once again, everyone. Today we're going to finalize our discussion on the airline's air passengers dataset. Let me load this again. So we were using the air passengers dataset, and so far we have, let me give this a name, AP, and then we said that the plot of this dataset shows us that this is not a stationary data series. Okay, and when we're modeling time series, one of the preferred model is ARIMA. And I hope clear sa inyo class what ARIMA is all about, kasi nagulat lang ako sa kabilang section. Tinanong ako kung ano ba yung ARIMA. So I got surprised because we have been talking about ARIMA for several weeks already. And medyo taken aback ako sa question kasi all these sessions pala parang hindi pa rin hindi naintindihan yung ARIMA. Now, class kung may ano naman, kung okay lang naman magtanong, pero yung nagulat talaga ako kasi ilang weeks na natin dinidiscuss yung ARIMA. I hope that's not your question. If it is, pwede naman kayo mag-review class, pwede kayo mag-search din sa internet kung ano nga ba yung ARIMA. But just a quick review, sabi natin, ARIMA is one of the methods used to model time series, okay, developed by Box and Jenkins. And however, there's a requirement for you to use that. The data should be converted to a stationary data series. You cannot model ARIMA using ARIMA kung hindi stationary yung data. Okay, so sabi natin, pagiging stationary, dapat stationary in mean and stationary in variance and covariance. Okay. All right. If we have transformed the data to be stationary, then we can now make use of ARIMA. Okay. In this case, parang definitely hindi siya stationary in mean, hindi siya constant mean, neither is it constant trend. Okay. So what we can do is you can immediately assume that you need to get logarithms here. Okay, pwede naman yun. Or some would prefer just detrending it first. Okay, and trying to model it without the log. Kasi the more simple the data, the better. Pero again, may mga restrictions and let's do that. No, let's first. So let me go down here. Okay, we have done this already before. So let me just summarize what we have done so far. Okay, let me go to the summary. So where's that? Okay. And ito, summary, no? Okay, first let's we said that anyway, what we can do is we can model the time series itself. We said that the good news is that pwede namang okay, sorry, let me first remove this. We can use the original data and use auto.arima to generate the best model. Okay, let me call this ARIMA best. ARIMA best, sige, ARIMA best one. Okay, so I'm modeling the AP, but the manual approach class is that once we have plotted the data and then we converted it into a stationary data series by doing the trending or doing getting the log, then that's the time we plot the autocorrelation function and the partial autocorrelation function. This is a review, no? sabi natin, the ACF and the PACF will allow us to determine if the model follows an AR process, an MA process, etc. Okay, so that's the manual approach. Pero sabi nga natin, may auto.arima na CR. So we can make use of that. So I'm creating this model, ARIMA best auto.arima AP. Okay, and then when I run this, it tells us that the best model to adopt is ARIMA 211012. Okay, ARIMA. So let me copy this. Control C. Tapos close ko na to. Kasi ang haba. Okay, so let me just write it here. So that's the model, diba? ARIMA 211. And what does this mean, class? This means that you have to difference the data, log 1. And then you're referring to AP data, diba, class, AirPassengers. And then you have to also difference the data sa log 12. Ito yung seasonal component na 12. So you're actually working on a data that's no longer yung AP. So this model is no longer the AP model. It's already a model that has been transformed by getting the difference of the log 1 and difference of log 12. So when you write the model, kasi pwede natin ilagay dito. Okay, so pwede natin muna i-ano muna, no? So let's call it ARIMA 211 underscore 010, diba? And then alt minus you have now ARIMA. Okay, so yung AP data natin, diba? Then order is equal to, this is the regular component 211, tama? Tapos yung sa seasonality is equal to list natin tama ba yung syntax ko? ARIMA AP, order 211, this is for the regular component. Seasonality is equal to list order is equal to 010. Dali, may syntax error yata ako. Para mas mabilis. List order seasonal is equal to, seasonal, hindi seasonality. My bad. Seasonal, list order, yan. So, para makita natin mas clear, order, ARIMA 211. Ano mali ko dito? 1, 1, 2, 2, 3. Kulang yung isa. Okay? Alright, we did this before, di ba? So after we identify the best model using the auto.arima, we can check by creating that model. Okay? So dito sa object natin dito, meron na tayong ARIMA best list of 18. We can also create that model coming from the suggested best model, ARIMA 211010. Ito yung component ng regular logs 211 and 010 for the seasonal. If I run this, dito class, if I get ARIMA underscore best, 1 coefficients, okay, so this is our model, diba? And also here, ARIMA 211, 010, coefficients, same thing. Okay, are you convinced class na pareho lang, di ba, yung na-generate natin ng auto.arima at saka kung mag-create tayo ng arima model. Are you convinced class? Clear yan class? Paki-chat naman please. Okay, thank you. Okay, so how do we write our model? Kasi kailangan isulat yung model. No? The model class is no longer AP. Nung nag-auto.arima tayo, di ba sabi natin AP. Unless you're redefining this. Okay, for example, my statement here na AP represents now the log 1 and log 12 difference series. Okay, if you define it to be that way, then it's okay to use this. Or you can create another variable and sabihin natin seasonal differencing na may differencing pa ng AP. Okay, so this will now be your object, no? Seasonal difference and then difference ng AP. And then sub T. So how do we write our model? Our model is equal to AR1 component, di ba? So auto-regressive, auto, self. Ano yung self na yon? Ito. Kung ano man yung object na yung class. Okay? The object, that's the result of the model. And again, class, AP, the original data series, is no longer the one that's being modeled here. In this, as far as this is concerned. As far as the equation is concerned, hindi na yung AP yung model natin. It's already a series that's different from AP kasi dinifference natin siya sa log 1 at saka may seasonal differencing. As you know, class, when we difference a data, we create another data. Okay? I hope that's clear. So this is equal to 0.596, around that, times SDAPT minus 1. 0. Sorry for the pen, 596 times SDAP T minus 1, sub T minus 1. Okay, this is now the series, the log 1 of this one. Okay, so how is this created? You generate another time series, diba? Where you get the difference of your SDAP. And that's this one. Okay, and then yung AR2 natin will be 0.214 times SDAP T minus 2. So that's another time series. No? That's another, that's a difference ng time series at one log each. So that's your AR2. No, sorry. I stand corrected. Hindi difference ang difference. It's just your T minus 2. Okay, wait, sandali. Let me clarify what I said a while ago. Did I say difference? No? Let me clarify that. So, illustrate ko na lang para mas madali. If you have this, hirap ng pen ito. Okay, ita pa yung grades. Clear ko. So what did I mean, class? So suppose your data is arranged from earliest to latest. From latest na lang. So I have here, ayaw mag-write. Ano ko talaga yung mouse ko, may problema. Ayaw. Oh boy. Kayo na pa to eh. Kayo pa ako nagkakaproblema sa mouse. Okay, anyway class, itong yung data natin, di ba? So it's autoregressive 1, autoregressive 2, kaya AR2, and your MA process. This one refers to your differencing. This one refers to your seasonal differencing. Na walang ARMA component yung seasonal data natin. Otherwise, kung may 1 yan o may 1, 2, then meron ding AR component yung seasonal data natin. Okay, so how do we write this? Sabi natin, we're creating a new object, which is now, okay. Close ko muna ito. Okay, okay. So, di ba yung object natin, let me just call it SDAP. So this is now our time series. Ito na yung difference at log 12, difference at log 1. Okay? And we're modeling this time series sub t, and it's equal to 0.596 times SDAPT minus 1. Okay? So you're technically using the time series itself, its regressive values, its past values, in order to model our time series. And then we have plus 0.214 times SDAP times sub t minus 2. So you now have the second log. Bali yung log 1, linag ulit natin siya, LAG, LAG. Okay? And then yung MA component, so that's model natin plus epsilon sub t, and then minus 0.982 times epsilon sub t minus 1. Okay? All right, let me pause for a while and pa-clarify nga class kung clear ba yun so far, yung model na yun. So given if you use auto.arima, you should be able to generate the equation and write the equation. Okay, class, clear so far? Paki-confirm kung clear. Okay, thank you. Wala naman nag-question dito. Okay, may question pala dito, Vic, sorry ha. What's the equation for MA1? Yung MA1, di ba, past error terms to, di ba? So the equation will be, okay, sulat ko ulit. Problema ko lang itong mouse ko. Okay. So yung AR, bali, yung minomodel natin is now a different time series, hindi na yung AP. It's now a time series that has been differenced twice. Difference at log 1, difference at log 12. Okay, sub t. So the first component is 0.596 AR1. AR1 is SDAP sub t minus 1. So this is the predictor. 0.596 times SDAP t minus 1. Iba yung SDAP sa SDAP t minus 1. So si SDAP t minus 1, it starts with the second value. Okay, if you arrange your data from the latest, so mangyayari, tatanggalin natin yung kahapon, kunyari, data ngayon, hanggang up to how many years ago, yung data kahapon, it will move to the first row. Okay? Tapos mababawasan na rin yung original data kasi yung SDAPT-1, kulang na ng isa yun. Dapat pare-pareho sila ng data. Okay, and then yung AR2, ang mangyayari, yung SDAPT-1, yung binawasan natin ng latest sa data, babawasan ulit natin ang data kahapon yun, yung first data. Okay, so mangyayari, yung 2 days ago, siya yung papasok. No? Okay. So I hope I can write that. Okay, so suppose we have 10, yung ngayon to 8, 9, 10, 11. So this is the data for today. This is your SDAP sub T. Now your SDAP sub T minus 1 will be, this will move here. 8, 9, 10, 11. Okay? And then if you go to the last one, ito kulang na to ng isa, tatanggalin na natin yung NA na yun. Okay? And then yung for AR2, SDAPT minus 2, papasok na ito dito. 9, 10, 11, etc. So technically, yung original data natin, rine-regress natin on past values of itself. That makes it auto-regressive. Okay? And then, so di ba plus 0.214 times SDAPT minus 2, and then you add the error term, epsilon sub t, and then plus, so this is, or negative, minus 0.98, minus 0.98, no? Times epsilon t minus 1. So these are your error terms. No? Epsilon t minus 1, log 1, me and a. Okay, Vic, did that answer your question?
Yeah, yes, sir. Thank
Okay.
you.
Okay, may question pa dito. We multiply the AR1 and the AR2. Yes. Yeah, Jerome. Clear na yung class? Pakichat ulit please kung clear. Autoregressive 1, t minus 1 yan. Autoregressive 2, t minus 2. Okay. Okay, so let's continue. Ay, mouse. Kailangan mang i-click mo ng 2 to 3 times bago mag-respond. Kaya yung first click ko kaya sumasakit yung kamay ko kasi I have to make sure that talagang piniklik ko ng malakas. This is not the kind of mouse that I used before. Very sensitive siya, konting lang. Ito naman, super insensitive. Okay, so ito class, sabi natin, since na-identify natin best model, we can check. So come up with an object, whatever that model is, 211010, and then you use the ARIMA function, and then AP, no? Yung order, yung regular order, at saka yung seasonal order, 211010, you'll get the same answer. Yan. And if you check, for example, yung AIC nito, so let's check the AKAIKI. Okay. So dito, we copy this. Control C, Control V, and AIC. Yung AKAIKI information criterion, which is used to 1017.848, no? And then if you just check dito, okay, 107.848. Pareho lang class, no? Pareho lang yung AIC. Okay. Now, had we used another model? Let's suppose we use another model. Sabihin natin, ang belief natin na kailangan i-log natin siya. I-log natin siya para yung variance constant. So, ang problema natin class, hindi automatically sa auto.arima, hindi automatically mag-generate ng log yung time series. So we have to impose that your AP should be log AP. Yan. Or if you want, pwede kayo mag-create ng isang object na LAP, tapos yun ang i-model mo. Okay, I'll just use log AP here, just to signify that we're as a comparator lang din na ito linolog natin AP, yung kanina hindi, di ba? So let's call this arena best 2. Ito natin to 2. And then okay, so let me run this first, yung unang line. And we can see here that the best model for the log AP is different, no? Diba? Iba siya. It's now, meron din tayong ipapa-difference pa rin sa regular at saka sa seasonal. Okay? So, ang imo-model ulit natin dito, class, iba. This is now the difference double differencing to, isang regular, isang seasonal differencing ng log ng AP. Okay, and you're getting an MA model, di ba? MA, tapos ito, papakita natin to, no? Parehong MA. Kanina, walang AR or MA component dun sa, sa seasonal. Dito, walang AR sa regular, walang AR sa seasonal, pero may seasonal na MA. Okay? So, did you get the same class? If you're following along, is it ARIMA 011, 011? Okay. If you're following class, confirm kung pareho tayo. Okay, so let me, okay, thank you. So let me run this to yung coefficient at saka yung AIC. Ayan, okay. Tingnan nyo na, no? So ano yung model natin dito for ARIMA best 2? What would be our model? ARIMA best 2. Okay, so our model will now be, again, sorry for I have to annotate na naman. So anong minomodel natin dito, class? So meron tayong, again, may seasonality, di ba? The different seasonality, however, class, let me clear first. So we have here, to close muna, bago makakapagbago na. Okay. So we have here, tawagin ko lang din S, you can name it any way you want. May seasonal differencing, may regular differencing, yung log AP. Okay. Sub T. And it's equal to MA1, and take note of this, seasonal MA. Kasi 011. So the answer will be, okay, so this is log 1 ang error term, but we have to first plot your E sub T. E sub T minus 0.4, let me just choose one decimal place, 0.4, epsilon T minus 1, and then minus 0.56 rounded off to the second decimal place, times what? Epsilon T minus 12. Okay, so that's our model class, seasonal MA1. Okay, pag seasonal MA2, then magiging T minus 24 na yan. Okay? So let me pause for a while, class, and ask you if you're able to follow along, kung nakuha, kung naintindihan, any clarifications. If you need clarifications, class, pwede i-unmute niyo muna yung sarili niyo. But the rest, class, kung okay na, paki-chat naman please kung yes, kung clear. Kung clear so far. First time natin nagkaroon ng seasonality component, no? And we will just have to refer to the ano yung seasonality index. 12 yun. Clear ko muna. After 0.4 is epsilon t minus 1. Okay. Minus 0.4 times epsilon t minus 1. Correct. Epsilon sub t minus 1. MA1 to di ba? Log 1 ang error term. Tapos naman ito SMA, seasonal to. So it should be negative 0.5569 epsilon t minus 12. SMA1 yun. Is that clear, class? Clear ba? Pa-chat naman please kung clear.
Yes, sir. Sorry, sir. Patanong, what's after yung epsilon sub t minus 1? Yun yung SMA 1, no?
Yung minus 0.56. Minus
Okay,
0.56 times epsilon t minus 12.
T minus,
Seasonal.
okay.
Seasonal siya.
Okay.
Okay? Okay, any other questions, class? Okay, question. Saan ginagamit yung AIC? Di ba? It's used to determine kung anong model ang mas maganda. Okay. Question. Which is the better model, class? Si ARIMA best 1 or ARIMA best 2? ARIMA best 1 or ARIMA best 2? Which is better, please? ARIMA best 1 or ARIMA best 2? Ano rule sa AIC, class? If you have several models and then you're comparing them using AIC, what's the decision rule? It's yes, correct. The lower better. The lower, ano. So, ARIMA best 2 is better. Okay, class? Clear? Clear? Pakichat naman please kung clear. Kasi yung AIC ng una, 1017. Ito naman, 483. Negative pa. So, mas maganda talaga si ano. Clear siya, class? Okay. Clear, clearly wrong. Okay. Clearly wrong, class, yung answer. Answer nyo, ha? Bakit? Why can't we say that ARIMA best 2 is better? Why? Bakit? Sabi nyo, yes, clear. Mas maganda si ARIMA best 2. Ang answer dun sabi ko, hindi. Mali. Dapat si ARIMA best 1. Di ba lower is better? Ay, o nga pala, no? Tama. ARIMA best 2. Lower pala. Lower is better. Pero mali, class. Hindi ARIMA best 2, mali yan. Kasi ang answer, ARIMA best 1. Eh, di ba lower is better? Ay, o nga pala, mali, class, mali. So, anong final answer, class? ARIMA best 1 or ARIMA best 2? Wala nang gusto sumagot. Sagot lang, class. Sige, try lang. Try. 2. Okay. Thank you, Jonah. How about the others? 2 or 1? Just write 2 or 1. Si John 2 din. Okay. student si Vince. Okay. Alright, sige, sagutin ko na class. The answer is si Vic. 1 na. Bakit Vic? Ba't naging 1?
Sir, pag ano negative na sir, hindi na counted as good fit.
On the contrary, kahit negative, no? Basta pag negative, basta the lower negative pa rin. So dito, in terms of numerical, talagang 2, no? Okay, pero mali yung number 2, class. Why? Because these two models are incomparable. Okay? You're talking of different dependent variables. You're modeling differently. Yung isa ang minomodel mo, SDAP. Yung isa, SDLAP. So, no comparison class. Okay? You can only use AIC if you're modeling the same variable. Okay, class? So, which is the better model? Parehong best model yan, based on the Autodat-ARIMA. If you're modeling yung SDAP, best yan, yung ARIMA 211010. If you're modeling the log of AP, ang best model is 010, 010, 011. Okay? Saan yan? Yung kanina. Am I right? 010 ba? Ay, hindi. Dito. Yung pangalawa, saan yan? Tinanggal ko yata. No? Basta 01, 010, 010. Ano, 010, 011. Okay. 01, 011, 011, 12. Okay, class? Clear. So which is the better model? No. You cannot compare, class. Based on AIC, no. Kasi you're modeling two different time series. Yung isa nakalog yun eh. No? Okay, thank you, Jonah. Yung isa hindi nakalog. Kung pareho sila pareho sila class, kung pareho naka-log, pareho naka-S, double differencing, then based on AIC, madidetermine natin. Okay, so I hope that's clear, class. You cannot compare. Okay? So if you're going to make use of the log, edi ARIMA 011, 01112. Okay? If you're just going to make use of the AP itself, the model is ARIMA 211 and then 010. Okay, I hope that's clear, class. All right, sige, punta ulit tayo dito, no? Okay. I-replicate lang natin to. Mag-comparison na lang tayo ng no? So, i-replicate natin to. Okay, this one. So, if we were using the other model, yung log, this should now be 011. Okay? 011. 011, 011 na to. So, dapat to, this should be 0. Okay, and then this should be class log na to, log. Okay, sabi nga natin class yung Autodat-ARIMA at saka si ARIMA, wala siyang automatic na ilolog niya, no? Walang ganun. So 011 and then seasonal is 011. Okay. So this is ARIMA 011, 011. Okay. 011, 011. Okay. So first time natin na-meet na may seasonality component, no? Yung seasonal, yung MA, and then it should be epsilon T minus 12. In this case, kasi 12 yung seasonality index natin. 0. This one we did a while ago, di ba? 211010. We did this. And na-compare natin na pareho lang talaga lumalabas sa answer. So, ganun din dito, no? If we run this, kasi let's say, nalaman na natin na pag linog natin sa AP, ang lalabas na model is ARIMA, SARIMA, no? SARIMA 011011, log 12. Pag mag-create tayo ng object na yon, na ARIMA 01, na model na yon, Okay, and then we specify kung ano yung order niya, yung regular component 011, then yung seasonal niya 011 din. And then we plot this. Okay, ano ba to? Arima, pareho lang to. Yung coefficients, so, tanggalin ko na to. Pareho lang naman yung ano, yung summary at saka yung coefficients. Okay? So we get this, no? Yung negative 0.4 at saka negative 0.56. MA1 din, SMA1. Okay? With the AIC in negative 483. And we said that it's not comparable with the other one kasi kanina yung minamodel natin yung AP, ito yung log ng AP. Okay, so let's now do some diagnostics with our model. So ito na yung ARIMA 211 010. Okay, so let me just share this with you. Control C para in the interest of time. Okay, Control V. Okay, so itong ano na to class, this is time series diagnostics. Ina-diagnose natin yung ARIMA 211 natin. This is your log, this is your AP model class. Okay, and then check residuals nung model natin, and then auto-plot. So if I run this, we'll have this plots. Okay, first is this one. Okay, it will plot for us the, okay, it will plot for us yung red dito, yung actual data. Tapos yung black is the predicted data. So kita natin dito yung predicted value, no? It closely resembles yung ano natin. So that's the power of ARIMA. Okay? So again, class, yung red, ito yung actual. Paano ko nalaman? Kasi it extends back here. Yung prediction naman natin, kailangan ng past 12, kailangan past 12 values, past 6 values, kaya nagsimula siya dito. But if you take a look, class, nakukuha niya nakukuha niya yung seasonality. Kuha niya. So that's why many prefer using ARIMA, the ARIMA model, kasi because of its power. Kasi nga, ginagamit natin yung log ng values of itself and also the log residuals. Okay, so next, tingnan natin to. Meron yung box test dito, no? Residuals from ARIMA 2110. Okay, you have the Q statistic here. P-value is 0.01. Okay, discuss natin to mamaya. Yung box. This is the null hypothesis here is that the residuals are independent. Gusto natin yung mga residuals natin independent. Ayaw natin ng correlated sila. Kasi pag may correlation sila, ibig sabihin nun, hindi pa nakaka-capture ng model yung correlation na yun. Take a look at this, tatlong plots dito. No? First, you have the residuals. Mukhang okay naman yung residuals natin. No? Yung residuals natin, the mean is at 0. No? Ang only difference is that meron mga spikes dito. May mga volatility spikes yung residuals natin. Now, going ahead of myself, this is actually telling us that perhaps pwedeng gawing arch, gawa ng GARCH na model. Kasi may mga residuals na hindi siya yung volatility, no? But yung volatility class kasi usually sa financial time series. Sa mga data na ganito, not really so much. Okay? And then here, kita natin ACF, may mga, preferably dapat wala ng significant spikes. No? Pero dito meron no? Meron dito. Okay? And then, this is the box plot, histogram of your residuals. And then we can see here yung kanina. Ito yung pinakita ko kanina. Okay. Now we go to, Okay, so ito yung using the TSM package, yung ano lang, yung same thing, yung PACF and ACF. Let me shut this. Ay, sorry. Mali, no? Mukhang kay Claire, si Claire, hindi naman sa akin sinabi. Sa kanya lang nakashare pala yung ano. Okay, sorry hindi ko na-share yung code kanina. Naka-clear lang pala. And then I failed to ask you kung nasundan yun. Yung previous yun kanina, no? Plus. Okay, and then residual analysis. Continuation lang naman to, class. It's just yung autocorrelation function yan. Chat ko ulit to everyone. Okay. So we can see here, dapat white noise na yung ano natin, no? Pero may makikita tayo dito, class, na ano lang naman, na may mga dito nakita natin to kanina, may mga significant spikes dito, no? But the rest are really insignificant. Ito din. Okay? So hindi siya parang perfect na no? Perfect na model. Okay? Kasi may mga significant spikes pa rin. And if we check yung box, ito, let me share this with you. This is to check yung serial correlation ng natin ng residuals. Gusto natin, class, na na our residuals should be not correlated. They should be independent of each other. So ang tinetest natin dito, if the residuals are independently distributed. And what do you get, class? Can you tell me, class, based on this test, if yung if yung ARIMA 211 natin, 010, yung residuals lang, okay, you get the residuals here. Log, okay, let's just use 24, and then type ng residual test is yung box. Okay, what do you get, class? Are the errors independently distributed? Are the residuals independently distributed, class? Answer, please. Are they? Yes, bakit yes, Jerome? Why did you say yes? Ano yung p-value na lumabas sa'yo?
Sorry, sir. Mali pala nakita ko. It's 0.03. So,
Yeah,
since the P is low, the
Yeah.
null must go, sir. So, it's
Correct.
not independently distributed.
Yes, thank you, Jerome. You're correct, no? So we reject the null hypothesis that the residuals are independently distributed. May correlation pa rin sila, no? And this makes the model, technically not acceptable, no? Pero ito na yung best na ARIMA model na ibibigay sa atin, diba? So either, class, accept it as it is or look for another model. And yung pag-uusapan natin susunod, yung next, it's the natural na extension of this, yung Garch model. Okay, but before we do that, let's now take a look at the other, although sabi nga natin hindi natin pwede ma-compare kasi yung isang log yung tinitingnan natin, ano? Okay. Sige, before we do that, let's just continue this. Tapusin muna natin tong AP model natin. So this is just a residual plot. Pareho lang naman to sa taas kanina, no? But anyway, let me just also share this with you. Control C, shut natin, Control V. Okay, kindly run that and you'll get this histogram with the density plot. Okay. So makikita natin dito, class, yung normality na residuals. Additional information lang yan actually. But you can actually test yung normality na residuals using Shapiro-Wilk test. Okay. Hindi ko na i-discuss yung, class, kasi on your own you should be able ready to look at the residuals. So let's assume we're going to accept this. Sabihin natin, okay na yan, no? We don't mind the hindi linear yung hindi linearly independent yung residuals natin. May mga residuals, nakita natin si PHCF at saka ACF na significant sila. Although nasa malayong lag na yun, no? Okay, so what we can do is, assuming that that's our model, let's use the forecast function. We can now forecast. Ito yung kagandahan ng okay. So let me share this para hindi na i-type. So ito yung sinasabi kanina ni Presley na ang gamit ng ARIMA is to forecast. Okay? But before you forecast, to model the time series. And whatever use you have for it, whether to forecast or to explain the data, kasi pwede lang naman explanation or forecast, no? So here we're using the forecast package. So we're creating this object forecast AP and use the forecast function of ARIMA 21101. Now take note here, hindi kasama yung residuals dito Okay, kasi hindi yung residuals yung pina-forecast natin, yung actual data, no? And the actual data class is your, di ba, saan nanggaling itong ARIMA 211? The actual data is your AP, no? So even if the model is 211010, even if this is now a different model, no? Actually yung pinanggalingan nitong 211, ang original data natin is AP. So pag finorcast to, ang ifo-forecast, hindi yung residuals ng 211, but rather the original data of 211, which is AP. Okay, so H is the number of steps ahead. So let's say 48 months, so that's 4 years. Ipa-forecast natin ng 4 years. And then ipaano natin yung confidence interval, may 80 confidence interval at saka 95. And then ipa-plot natin si forecast AP and then ipa-print natin. Mamaya natin ipa-print yung values. Ipa-plot na muna natin siya. So let me run this too. Okay. And then we can see here now, ito na yung class. Hindi niya pinasok dito yung confidence interval. Pero nasa plot yan. Alright? So you can see here class, the plot for the next, yung age kasi natin is 48 yun, so 4 years yun. Ang data natin hanggang 1960, so may plot dito may forecast dito ng 1961, 62, 63, 64, dapat hanggang 64, no? Hanggang 1964, kasi 4 years. And you can see here, notice how the forecast is it really mimics yung behavior ng data natin. Okay, pakichat nga please kung nakuha, please. I'd like to know if you were able to get the forecast. Okay. Okay, thank you. Are there any questions? Okay, good. Good, thank you. Okay. So ito yung forecast natin, no? 4-year forecast. And then, pwede natin pa-print yung makalagay dito. The non-existent lead arguments will be lead. In-ignore siya dito sa plot, no? Pero dito sa pag-print sa kanya, kasi 80 at saka 95 dito. Gusto natin hindi siya in-ignore dito. So here class, you have the forecasted value. Yan. Okay. This is the point forecast. Ito yung nasa line mismo. And then ito yung 80% confidence interval, which is lower. Kasi di ba pag maliit yung confidence natin, mas maliit yung range ng data natin, ng forecast natin. 431 to 460. Yung 95% confidence interval, if you want to be mas highly mas confident ka, lawakan mo yung pag-forecast, di ba? 423 to 467. So the data here is 1961 hanggang 1964, December 1964. Okay? Alright, class, nakuha itong forecast? Paki-chat naman, please. Okay. Alright, just to, not to compare, but to see ano mangyayari sa model natin kung kinuha mo natin class yung ano. If we got the, ito, no? Ito. So, copy lang natin. Tanggalin muna yung mga output para makopy ko hanggang dulo. I remove the outputs, Control C, and I'll just change the oops. Okay, so ito class yung isang ano naman natin, isang model natin. Checking model arena. Ito yung ano yung ano yung model natin dito? 011 011. This is the log ng AP. Linog natin yung AP niyan, di ba? Alright, so na run na natin kanina yan, yung ARIMA 011, 011. And then, palitan na lang natin to. Para mas mabilis class, Control F. And I'm going to change this with on my mouse. Control D. Replace, Control D. Pero ito, okay. Replace. Pinapalitan ko lang lahat plus yung sa next parts. No? Para mas mabilis kasi matagal kung type ko pa. Okay. Okay. Baka bumalik ako. Yan, okay na. No? I'll call this ARP1. Workers 1. This one. Okay, so I'm just testing the ARIMA 011 natin. Narana natin to kanina, no? Yan. And then let's take a look at the diagnostics here. Let's see how the diagnostics look like. So ito yung ACF class, okay naman siya, no? Okay, dahil yung box, mas mababa yung PIB. I-check natin yung box ng ano. Okay, ito, mamaya sa stop yan. The residuals are okay, mas lesser yung volatility, no? Mas normally distributed, pero may mga ano pa rin, no? Even the log na AP, may mga significant spikes pa rin siya. But it's Parang either surrounding of yan or not much. No? Isa nga lang nakita natin at log 36. Okay, and then this is also the plot. Okay. And then let's go here. Tingnan natin itong ACF at saka PACF. Okay, so mas ano siya, no? Mas meron dito isa, no? Dito. Pero compared to yung kanina, ACF, PACF, mas walang autocorrelation tong yung linog natin. And if we test yung box test niya, ano, okay, 0.3309. So here, class, dito sa yung linog natin, okay, we failed to reject the null hypothesis here. Okay, so here I'd like to comment here that it really makes sense. Natingnan talaga natin kung yung meron tayong preliminary na na investigation kung yung data natin stationary ba or kung hindi, anong gagawin ba diyan? Kung i-difference natin, natanggal ba yung definitely matatanggal yung trend, no? Or baka may kailangan pa ng second differencing or kailangan yung ilog para matanggal yung non-constant variance, these things, no? So what we first did was just to model AP, no? Di ba? Tapos lumabas naman based on UR KPSS test na naman na yung difference ni AP is stationary. Okay, based on that test, no? Pero alam natin na na based on the plot, hindi siya stationary in invariance. Okay, so ito, we can see here that we're getting a statistical test na yung natin, yung residuals are independently distributed. Okay, and if we check the okay, so mas normally distributed yung yung residuals natin compared to yung model kanina. And then, now, if we forecast this, okay, anong mangyayari dito, class? Tingnan natin i-run natin to for itong dalawa muna. These two. And let's see the plot. Yan. So, dito din forecast in 4 years. And then if we get the prediction, okay, itong tanong ko, class. Take a look at our data. So ang predicted value niya sa January 1961, yung point forecast niya is 6.11. Okay. So tanong, pag tinanong tayo, class, ano yung forecast na air passengers nung January, yung first month after the actual data? Anong sagot natin? Anyone, please? What will be our answer? Bakit yung kanina, class, yung forecast natin, bakit yung forecast ito? Tinanggal ko. Where is that? Asan yung forecast natin ito? Forecast AP. This one. Let me run this. 445, which is really the data, di ba? Pero ito 6.11. Okay. So paano yun? Bakit ganun, class? Ano yung difference niya? Come on, class. You can answer this. Anyone, please? Yes? Unit change, okay, big. Okay. Ano ba yung data natin dito sa forecast AP1 natin? Okay, related, okay. So unit change, okay, sabi ni John, log, okay. Naka-log kasi yung data natin, di ba? Remember, this is log AP. Okay? So ang forecast niya, syempre, log AP din. Di ba? Okay, so just be cognizant of that. Eh kung ang gusto mo, class, yung AP na forecast, ano gagawin natin? Eh di, i-convert mo yung log AP to AP. Okay? So, paano i-convert yun? I'll give you a, hindi ito yung complete answer, okay? But I want you to discover paano. One way to get the log, to remove the log, is to get exponentiate it, no? Pero hindi pa yun yung complete na na process, So, if I get the first prediction, itong 6.11, okay? Control C, and then, how do I remove the log of that? Exponentiate natin, e to the control V. Okay, what do you get here? Kasi log to di ba? Log AP to. Hindi siya yung AP. Unlike yung kanina, AP yun. Ito log AP. So what do you get, class? 450. So how does that compare with the other one? 445. Okay, ang tanong. Yeah, thank you. Thank you, Jerome. The question is, yun na ba? Okay, or may adjustment pa ba yan na gagawin? So I want you to discover that for yourself. How do I now convert yung forecasted values? Is it just simply, so actually you can generate, you can generate an object, let's see, natin fit, for fit na lang. Fit underscore yung predict na. Pred na lang ng ARIMA 211 010. So we're creating this object in predict, and it will be from yung model natin, yung ARIMA ito. Wait. Kasi ito ang bibigay lang sa atin ito class yung ano lang to yung, sorry, this is just the fitted values, no? Ang gusto natin yung, paano natin ma-generate itong itong object na to, yung forecast natin. Mouse, please cooperate. Okay, ito class, no? Forecast AP. Ito yung forecast natin sa una, di ba? Ano laman ito? Asan dito class yung mga values ng forecast natin? We're here. Saan class? Yung sa mean. Okay. Sa mean. So if I create this spread, ARIMA 211010, yung forecast AP ng mean. Okay. And then view yung spread haba. Yan. Okay. So we have to convert this into para mag-view siya, kailangan ma-convert natin siya into kung pwede siyang ma-convert ng TS object na to. Okay, yun siya. No? So ito class, no? 4, 4, 5. Ito yung object natin. Right? And then you can compare this with the other one. Okay? So, pwede natin i-generate yung isa naman, tapos pwede natin siya i-combine para makita natin yung difference ng forecast, no? Ang forecast natin dun sa may log, diba? It's the log values. Are you getting me, class? Yung mga log values yan. So, as your quote-unquote assignment na hindi ko naman i-collect, no? So, for quick discussion lang to next time we meet, is how do we now convert this into a into a yung actual na kasi log to eh. Diba log to? And in fact, it turns out na diba mas in terms of residuals, yung model natin na kinuha natin yung log, wala siyang serial autocorrelation, diba? Based on the Lung box test. Ito. Unlike the other one, because we did not get the log of that, hindi natin scale data natin. Ang nangyari, yung residuals natin dun sa towards the nagkakaroon ng autocorrelation. Okay? Alright. So, any questions so far, class? As to yung paggamit ng ARIMA, tapos yung pag-check ng residuals niya, tapos yung pag-forecast. Okay, so depende, class, kung ano yung object na ginamit natin sa model. If it's the original data, dun sa auto.arima natin, whatever forecast you'll get out of that will be the original data. If it so happens that pag nag-auto.arima tayo, linog mo yung data, then whatever forecast you derive using the forecast function from the model, from the model that you generated using auto.arima, okay, ang magiging forecast niya will be yung log values. So, madali lang naman i-convert yan. In fact, yung initial na ginawa natin, exponential ng log. Kasi exponential ng log is actually the value itself. No? Pag kinuha natin yung exponential ng value, okay, matatanggal yung log. So, kaya naging 450 something to it. No? So, ang tanong ko na lang, yun lang ba? Or do I add a particular value there para ma-convert yung ano? So, try to find that out, class. Madali naman malaman yun. Okay, so I have, wala na, 1 minute na lang. No? I was supposed to, I'm going to send class a video, which is from another class. Ito. No? Hindi ito. It's the okay, ito na yung class yung ito na yung mga steps din na gagamitin dun sa case kasi yung sa case class, financial time series talaga, no? Yung ginamit natin ngayon, AirPassengers, hindi naman siya financial time series. Okay? So, whatever, ito talagang kukunin yung dapat yung log. Kasi returns ang pinapamodel sa inyo. So you have to get the log returns. And if you recall, class, getting the difference ng log ng data is actually getting the log returns. Okay? So ito talagang kukunin natin yung log muna, tapos get the difference to get the compounded returns. Okay? And then, check again, yung ARIMA process pareho. You can make use of the auto.arima. Pero siyempre, i-test nyo muna, tingnan nyo muna yung usual na kung stationary na ba, and then you determine kung kailangan bang, well, forced to kayo na i-log talaga, no? Kasi returns yung pinapahanap eh. Okay, and then we generate the ARIMA. And then you'll notice na pag print natin yung data, makikita nyo ang daming volatility. Ang daming mga spikes na pataas. No? Okay, sandali pakita ko lang ito. Just as an example, it's already time, plus 1 minute time na. Let me just show this to you. Okay, so na-load ko na ba si PDF? Okay. Ano ko lang library. So dalawang packages, actually dalawang main packages ang gagamitin natin. Si PD Fetch at saka si Quant Mode. Okay? Alright? So here, making use of the PD Fetch, I can now fetch data from Yahoo. Okay, kunyari ito. No? Let me just show you this to you. Okay, so GSPC is Standard and Poor's 500. Okay, talagang time na. So let me stop here, class. So andito pa rin yung mga unit root test, no? Okay. Andiyan pa rin yung mga unit root test. However, ito ang hinahanap natin dito yung ano, ang minomodel natin yung ano. Ito, example class. Take a look at this. Okay. Ito yung tinatawag natin na volatility clustering. Okay. Ito, sa point na to. Most probably this is during the global financial crisis 2008. Ito yung COVID, no? So pag minodel natin yan, okay? Malamang class magkakaroon ng ng mga dependent sa mga residuals because of this volatility clustering. Okay, so usually pag time series hindi na model ng ARIMA. Okay? So ito yung data natin, di ba? So definitely hindi siya stationary in mean. Okay? Alright, so ang mangyayari dito class, okay, we will have to do a step further. Pag na-model natin yung ARIMA, papasok na si Garch. Si Garch ang minomodel yung volatility. Si ARIMA minomodel yung returns, pero hindi kaya ni ARIMA i-model yung mga spikes. So dun papasok yung next lesson natin, which is part of the case, yung Garch natin, yung generalized autoregressive conditional heteroscedasticity. Okay? All right, so let me stop the discussion. Let me stop recording.